Hello again, and welcome to a video where we're at the point where we can pretty much be solving any literal equation that I can throw your way. We've spent a lot of time so far talking about how we can rewrite a lot of our different formulas, including Pythagorean theorem. We talked about simple interest, and we did some area formulas. And you should have already watched a video on how to rewrite something from standard form into slope-intercept form, all right? So now we're at the point where I should be able to give you any equation, and I want to be able to solve it for any given variable. And that's what we're going to do here on this page. I'm going to go through these 16 examples with you, and then you guys are going to practice some more on your own. All right? So we're going to dive right on in here. So for number 1, we've got that g equals 6x, and we're going to solve it for x. So if I'm trying to solve this thing for x, I would just divide both sides by 6. And here that cancels out. So x equals the g divided by 6. G over 6. All right, for number 2, we have u equals 2x minus 2, and we're going to solve this for x. Now, normally you guys know when we're trying to solve for x, there's just generally like a number here. And you would start by saying, okay, so I'm going to do a plus 2 and then a plus 2. And then you'd say, okay, if this was an 8, I'd add 2 and get a 10 over here. The only catch is we don't know what u equals, so I don't know what the number over here should be. The best I can really do is say it's going to be just u plus 2. Okay? Now that cancels out, and on this side we have 2x. So what we need to do now, and I know that this is going to kind of bleed into the next example, we're going to divide this by 2 and divide this by 2. And I'm going to cancel that out. So x here would be u plus 2 over 2. Now, technically, since you guys have already learned the heart method, something that would be an acceptable answer is to say I've got this 1u divided by 2, so this is a half u. And then 2 divided by 2 is a 1, so there'd be a plus 1 here. So both of these are equally acceptable answers. And next school year, it depends on the scenario and the type of problem. And your teacher either will want you to do the heart method to get this answer here in purple, or they will not want you to do the heart method. And if they don't want you to do the heart method, then you'll just leave that answer in red. So it really just depends on next school year, and I'm going to leave both here. The 1/2 u plus 1. All right, now we're on number 3. So we're going to solve this thing for x. Now right now we have z equals m minus x. So what I really want to just do is add x to both sides, because then now on this side I have that x plus z equals m. And if I want to solve it for x, now all I have to do is minus z and minus z. So z's cancel out, so m minus z is our final answer, whatever m minus z would be. All right, now for the next one, let me just erase some of the math from the problem above it. All right, we're trying to solve g equals ca just for a. So anytime we have a coefficient, we're just going to divide both sides by c. So here we have that a equals g over c. So g over c. Okay. Now for the next one, if we're trying to solve u equals x minus k for x, well, the only thing that's with x is this minus k. So I'm just going to add k to the other side. And I'll add k to the other side. And the k's would cancel out. And then here we just simply have that x equals u plus k. It wouldn't be wrong to put k plus u. And technically, I guess alphabetical order should win. So technically it should be k plus u. But addition is commutative, so that answer right here is fine. And next school year, it won't matter how you put it. If you have k plus u or u plus k, that's fine. All right, now for number 6, if we have g equals c plus x for x, all right, well, we have a positive constant right here, the c. So we're just going to subtract c from both sides to cancel it out. And we have solved for x, and that would be g minus c. So we're not supposed to have any numerical answers here. We're just saying this is what you would be doing to get x. You would just take whatever this number is and subtract this number, and you have x. All right, so now we are on number 7. So we're going to solve this thing for a, which is currently a denominator. Now you guys know to get rid of denominators, we're supposed to multiply both sides. So I'm going to multiply both sides by a, and I'm going to have over here, I'm going to have au, and then on this side, it's just now k. So if I'm trying to solve for a, I just need to get rid of u. So I'm going to divide both sides by this u, and the u's cancel out. So we have a equals k over u. So a equals k over u. Okay, for the next one, for x, a lot of these, you can kind of get the hang of this. If we're solving for x, we're going to divide by the coefficient here. So x is g divided by c. All right, now we're on number 9 here. So if it's 12 a.m., 12 a.m. and it equals 4, we're going to solve for a right here. This is a lot like the I equals PRT one where you'd have like a P, R, and T, and we're trying to solve for that middle letter. So to get A all by itself, we're just going to divide both sides by the 12 and the M. And here we'll divide by 12 and M. The 12 cancels out and the M cancels out, so A is all by itself. And then 4 divided by 12M is what we're left with. Now this is not the final answer because some of you might realize that 4/12 could be a fraction which reduces. So really, we've got that A is a 1 over 3M because 4/12 reduces to 1/3. So I'm just going to put equals A on this side, and then I can box this. All right, we're on number 10 now. So we're trying to solve for x, and if x is with the -3, I can get rid of the term that's separated with a plus sign by subtracting on both sides. So I'm going to cancel this out, and I've got -3x left alone. And here, kind of like we talked about with the a standard versus y equals mx plus b video, you want this part to come first. We have the -2c, and then the constant will come last. That's a -3, so I'm going to put that there. And now we're ready to divide both sides by this -3. So since you guys know the heart method, it's okay that I show you that the -2 over the -3 would become a 2/3 c. And here, a negative divided by a negative is positive, and anything divided by itself would be a 1, so this would be +1. So x here equals the 2/3 c and then +1. 2/3 c plus 1. All right, for number 11, if we're trying to solve for a, this one's going to be quite simple. We'll just divide by m. And like I was telling you guys, that your teachers next year will kind of talk you through when you do need heart method versus when you don't. I talked about that up here. I mentioned here with the divide by 2 that you might be asked to make that the 1/2 u and that this would be a 1. Now right here, I definitely went ahead and just showed the heart method. But this would be an example, y'all, where you might not need the heart method because we don't have any numbers actually anywhere. So we would just say whatever n plus p is, that would be the numerator. And then everything would be divided by m. And we can leave that one like that. We don't need to do heart method. If we did the heart method, it would basically be n over m. And then plus p over m. And that is something you could write down in red, but I'm not going to box it because I really don't think you're going to have to do the heart method if it's all variables. It should just be n plus p over the letter m. All right, sweet. Now we're on number 12 here. So we're trying to solve for letter A, which is up here in the numerator. So first I got to get rid of b, which is a denominator, and I'm going to multiply both sides by b. So I'm going to have BU or UB. It doesn't really matter, but I'm just going to write B times U. And then we have equals A times K. Now, if we're trying to solve for A, I'm going to divide both sides by K. A is all by itself. The K cancels out. So BU over K is what A equals. And like I said, if you'd rather think of that as U times B and think of it as UB, and then divided by k. That doesn't matter at all. Both of those are equally acceptable and equally right answers because multiplication is commutative. So up top there, it wouldn't really matter which order you had. All right, so we only have 4 more examples. We're kind of flying through on this video. So for number 13 here, if we're trying to solve for a, which is right here, all I really need to do is get rid of c. And since it says minus c, I can just add c to both sides. Now the c's will cancel out, and so we've solved for a. And over here, we're just going to leave d minus r, and then we just add a c to that. And that's it. All right, for number 14 here, we have xm equals np. So I'm going to solve this for x. And to do that, we just need to divide by m and divide by m. All right, x is now all by itself. And here we're just going to leave np over m, and that's it. All right, for this one here, we've got z equals b plus m over a, and we're trying to solve this thing now for a, which is right here. Now I have a constant, so I cannot start here with a. I got to take care of b first. Since it's positive, I'm going to be subtracting b on both sides, so I'm going to go ahead and write z minus b, and then equals m over a. And now when I'm trying to solve it for a, I'm going to multiply this side by a to get rid of the denominator here. So this whole side, the z minus b, all of that gets multiplied by a. So I'm going to put a like this, almost as if it were to be distributed. And now we have it for m, but we want to solve it for a. So this next step, we're going to divide by the whole thing that's in parentheses, z minus b. And when we do that, this whole thing in parentheses cancels out, and a is all by itself now. And then we're just left with m over z minus b. It's okay to not write the parentheses in the final answer. You can see that we don't need them. In fact, I only used them right here and created them when I was showing a times that whole entire thing. But you do not need them for the final answer of z minus b. All right, and we're on the last one here for page 6. So if I'm trying to solve this for letter x, I'm going to add the c to both sides. So I've got g plus c equals x plus y. And now to get x all by itself, I just need to minus y and minus y from this side. So we're just going to leave it as g plus c minus y, and that equals x. And we've solved it for x. So I just wanted to get you guys started with a lot of these examples and work you through lots and lots and lots of different examples to just show you a wide variety of what I could be throwing your way. And that concludes this video. Thank you for watching.